So they come in back behind and plug into the bladder. Your trigon, it's because it kind of makes it look like a little triangle when you're looking at that bladder, and you'll be able to see that. Just like the inside of the stomach, it has rugae, so kind of wrinkled and folded up. Because remember, this bladder, it's a detrusor muscle. It's an actual muscle, smooth muscle. We can't control it. But we have cells that make up this bladder, and they were called transitional epithelial cells. So what did that mean? What does transitional? It was the only example I gave you of transitional epithelial. We had squamous, we had columnar, we have cuboidal epithelial, but now we have transitional epithelial.
And then it can like stretch.
Yeah, it changes. It transitions from one to the other. So if you're sitting here right now and you do not need to pee, then your transitional epithelial of that bladder look like columns. They look like that. So all the way around, they're big and tall. But if you got to pee and they're all stretched, that bladder is just full of urine, then they transition into looking almost like squamous cells. So if you have to pee, it would be my transitional epithelial is stretched out, or my transitional epithelial is flat. That means I need to pee. So smooth muscle, stretching that out, and we'll talk about the urination or micturition reflex in just a second, where when this stretches about 200, 250 milliliters, we got to pee. Gives us that signal to our brain, we got to pee. You have some muscles here, your internal urethral sphincter, and that one is not under our control. So we really can't tell that one to open or close. When it gets stretched out, it does it. But we do have one that has skeletal muscle control, and it's our external urinary sphincter. That one is the one that we can allow our bladder to get up to 300, 400 milliliters and not go pee. Because you're like, oh, I can't go right now. I got to sit here and listen. I can't get up. So you'll cinch down that sphincter. That's the one we do control. External urinary meatus, that's just the opening. Meatus is just an opening from the body. So, where it's located is important. On both male and female, it is behind the pubic bone. So that big bone that you can feel on yourself, it's sitting right behind it. So the urethra obviously is two different sizes on male and female. And why, looking at both of these illustrations, why do you think females end up getting urinary tract infections more often than males?
Direct entry.
Not a direct entry, no. It's closer. That's the problem. So, females, we have lots of bacteria, colon, let's get it right, colon, and when we do have some here, we'll talk about this in just a second. But colon, we have a lot of bacteria, E. coli, that doesn't have very far to travel. Whereas this colon and bacteria, it has, if I could draw, it has a long way to go to get to that urethra. So they're at a little more advantage than we are. Think about those residents that you cleaned this week. Females, all of that E. coli poop, all in the urethra. Nothing you can do about it. With the males, depending on how bad it was, sometimes it is. But for the most part, no. They don't end up getting their urethra dipped in some poop. I told you I'd talk about this other opening in just a second. We do have some changes, hormonal, estrogen levels drop, you start seeing more bladder infections because it will cause more bacteria imbalance in the vagina as far as bacteria and yeast. You'll see more yeast infections. Okay, urination, what causes it? We do have stretch receptors, send information to the brain, particularly the pons, and it says, hey, let's go ahead and pee. So, we got a